So I want to start again just with the usual overview, right? Again, the session here is the training track is intended to include 4 web sessions, of which we're currently at the 2nd, as well as a hands-on workshop in early August where we can go through more details and give people some focused time to work through some of this stuff, with the goal of expanding the pool of people who have access to network data and who can both validly execute scientific projects and who can serve as the lead data site for projects that involve PEDSnet as a network. As you can tell from reading the slide, our May session is around data request fulfillment, right? And so we're going to be focusing today on both the process and the high-level considerations that we use in trying to respond to data requests to the network. We will, in subsequent sessions, get down more into the details of the software tools that we use and some of the details about how we execute queries. But today, what we want to do is go through the data science of responding to a data request. Right? I think everybody here understands the broad context of this, but I want to highlight that, in particular, we're doing this in the context of a learning network. So part of what we are trying to do is respond to investigators who want to conduct science using network. They may be attracted by the scale, they may be attracted by the depth, they may be attracted by the fact that it's where they live and where their collaborators live. We are also trying to develop the science of networks here. So how we address the data, how we make effective use of these kinds of data. And all of this is in service of trying to take better care of patients and trying to improve child health. So we tend to focus our requests on topics that we think have the potential to change the way that we understand child health. That still leaves a fairly broad range. So if you look at some of the kinds of work that we have done, they include supporting government regulatory agencies around acquiring public health data or establishing large-scale programs to address disease areas or research areas of interest. We see a lot of academic requests for observational studies, less often to date for prospective interventional studies, but some of that as well. And from a technical level, we get a lot of traffic asking, how do you handle data at this scale and how do you operate in data? We are seeing increasing interest from private sector funders. In the case of biopharma industry, that often centers around a product that someone is testing or wants to bring to children. This also includes foundation work. And then finally, we separate out, but want to mention that we also do a fair amount of work in PEDSnet in connecting our data to other folks' data. And while that's different from the process of generating a scientific analysis plan, it is a part of the work that we need to do in order to validly execute studies. So we'll talk some about each of these areas today and about how they go into addressing data requests. Right? We're going to talk about them in the structure of an overall pipeline through PEDSnet and PEDSnet for data requests. Generally, this starts when someone has an idea and they think the network might be a useful resource to answer that. And the way that connection gets made formally is that the requester completes a web form, what we call a front door request, to either PEDSnet or PEDSnet. Now, they may have been referred to that web form by folks who have already been engaged with the network, or they may have found it on the web, or they may have seen it in a published paper. But we do try to route everyone to that form so that there is a kind of clear record of what the request was and all of the information in one place to get to the people who need to review it. When that request comes in, it's very quickly reviewed by the project management office to make sure that it's something that is hypothetically feasible, and then by the data and research committees to see whether this is a study that could be addressed by PEDSnet, can make use of the data network or the methodologic resources, represents valid science, has appropriate methods, things like that. If the study is reviewed positively and accepted as a PEDSnet study, then the research committee, formerly known as the executive committee, will then add it to the list of things that PEDSnet is doing and put it in the queue somewhere, so that we can focus how PEDSnet is working on the topics that we think have the highest impact. As a study comes up, it then goes through a bunch of the administrative processes that I think everybody here is familiar with, either from the world of grants management or from the world of request and project management, and then comes to the data science team in order to address the data portion of the request. So everything we're going to talk about today is going to be what happens in that gray box down at the bottom, but we will try to connect it back to the process outside fulfillment of the data request. That leads me to try to summarize the things that we'll discuss today. What kinds of data requests do we get? How do they relate to, how does the type of request relate to the kind of information you want to return? How do we convert questions the way an epidemiologist or a health services researcher or a disease biologist thinks about them in terms of specific aims and methods into questions that we can actually address to the data? And then with those specifications, how do we generate queries and analyses that will execute against the data? In particular, we want to spend some time talking about how we address the difference between queries that will return analytic results, even if those results are just counts of patients, versus queries that will return actual row-level data to the investigator, because the way those queries are laid out differs, the kind of information they return differs, and what the investigator is able to do with the results differs. So you want to think about them a little bit differently. And then finally, we're going to talk about some of both the administrative and the technical tool chain that we use in order to ensure that everybody knows where projects are in the network, that we're making effective reuse of work that we've done before, that we're executing things efficiently, and that we're generating data that can go back to investigators without incurring extra risk to the privacy of patients and families whose data may be included. Right, so with that introduction, I'm going to hand off to Connor to just summarize the types of data requests and talk a little bit about some of their characteristics.
Hey everybody, so I'm just going to give an overview of the types of data requests that we receive here at PEDSnet. So on the next slide, looking at the schematic, we can kind of get an overview of it. The three things we're going to be talking about are the purpose, the evaluation, and ultimately the output of the query. So the purpose and evaluation will interact with each other and ultimately lead to some predefined output that the investigator is looking for. So to give a quick definition of each of these, the purpose is pretty straightforward. It's what the sponsor is looking for, and that includes some interaction with our team in order to really determine what level of formality and collaboration is needed. The evaluation is looking at what the context is around the query and how much work it's going to take to fulfill the request. And so that's going to involve us as well as the research committee and as well as the sponsor themselves. And then finally, we're also going to be looking at the output of the query. So this can take all sorts of forms. It can be a simple grab with some counts, or it could be an entire data set, or it could be multiple iterations of each of those and develop from something that's as simple as just a couple of counts and ultimately wind up with a data set. So looking at the purpose in more depth, some of the simplest things that we receive are feasibility requests, wherein somebody has an idea of a study that they would like to, or a study or something that they would like to look at, and we just grab some aggregate level output. So it could be just some counts of patients who have some condition of interest, as well as some sort of medication of interest. Another thing could be a little more in-depth as a report, where we're looking at the population that satisfies certain criteria and looking at breakdowns of that population in terms of what medications are they on, what's their healthcare utilization, things like that. So this can really vary in scope in terms of what the level of work is that's going to be involved in creating the report and what the sponsor is interested in looking at. Next up, we have an academic collaboration, which is a little more in-depth, a little less formal. So that's where our data scientists are interacting with a researcher in order to kind of determine what analysis would be of interest. And we have a lot of input as data scientists on what is feasible with our database. And ultimately, we're trying typically here to aim for a paper or publication. And then finally, we have data center work, wherein we act as something of an honest broker to try to link multiple data sources. And an example of that might be our PPRL or the WELF study, where we're taking in data from One Florida and utilizing it in conjunction with ours. So, in looking at the evaluation, the first thing we want to take into consideration is the complexity. How much work is going to be involved in fulfilling this request? So are we going to have to create a lot of fields that aren't currently captured in PEDSnet? Is our data quality where it needs to be to fulfill that request? Do we have to create additional mappings from our data to some other data source in order to meet the needs of the sponsor? And then funding. How much of it and where is it coming from? So we tend to prioritize private industry, I think largely because the funding that we get from private industry tends to stick around after the completion of the project. And also prioritization. So this is also something that we have to talk about with our research committee to kind of see what the broader scope of PEDSnet is and what the trajectory of it is, as well as how much time is going to be involved in creating and fulfilling a request from a sponsor. And ultimately, where does it lead us? When, what is the timeline, and what else do we have on our plate at that point in time? Finally, we have the output, the end goals of each of these requests. So the simplest things might be just aggregate counts and metrics, such as medians and means. These can really range in complexity based on the criteria that are applied to our database and the population of interest. And the analytic outputs are the aggregate outputs and then some. So something that might require a little bit more insight into trends over time, some sort of data visualization or hypothesis testing. And finally, we have person-level data sets, wherein a sponsor is looking to receive some subset of our data and perform an analysis on it based on their area of interest. So in this case, the data scientist is going to interact with the sponsor a lot in order to determine what is needed from us, what level of information we're willing to provide to that sponsor, and ultimately, are we going to be able to provide a data set that includes all the information they would need to do something like publish a paper?
Okay, thanks. So again, as we do, why don't we pause for a minute and just ask what questions folks have on the kinds of requests we get or the sources we get data from, data requests from, sorry.
Hey, this is Janet.
Go ahead, Janet. Go ahead.
So, are you saying that it's one intake form for PEDSnet and PCORnet?
No, we're saying that each has their own intake form. They look very similar to each other. They just go to different places. And so if you submit the PCORnet form, it goes to the PCORnet coordinating center and gets sort of routed through that administrative process. The PEDSnet one goes to the PEDSnet coordinating center.
So how do investigators decide which one to pick, or do they just submit the requests and there's some process that tells them who to get routed to?
So there's a little bit of crosstalk between the two. You know, if somebody submits to us and it looks like it would benefit from the wider network, we send it to PCORnet and vice versa. I think one of the biggest distinguishing factors so far has been pediatric focus. So if somebody's asking a strongly pediatric question, then PEDSnet tends to point them in our direction. Conversely, if someone wants to study, transition to adult care or that sort of thing, we tend to route it to PEDSnet because we lose the patients when they transition to adulthood. Some other distinctions have been the kinds of analysis that are going on, or even just where the investigator lives. We're more likely to get a request from somebody who's at a PEDSnet site and has collaborators at other PEDSnet sites. PEDSnet is more likely to get the request if the investigator has collaborators at non-PEDSnet sites. Okay, so starting then from that front door request, what we want to do is walk through how we get to the specifications that we need in order to be able to fulfill a data request. And essentially, what we want to do is conceptually walk through the process from a really high-level description of the query, what you might think of as a specific aims level, to what we call the scientific specification of a query, think analysis plan, to the technical specification of a query, think roadmap for getting to the data. So I'm going to hand over to Levon to talk about the specific form that we use to try to guide people through that thought process.
Okay, thanks. So yes, I'm going to talk about the specification form. I may call it the spec form. And basically, this is a communication tool that you can use when you work with investigators. We think that this is going to be pretty useful because it will kind of be a place that all of the requests can live and gets into the details, as Charlie mentioned, the high-level overview, but also down to some of the nitty-gritty details. And it's useful because as this document gets populated, this can be pointed to as like, this is what we agreed upon for this query. And the goal is to try to capture all the main data elements they want to make sure they can get the study team is getting the data set that they are interested in. And we're hoping this will be a standardized approach that you can apply to different queries across studies. It is a large Word document, and I would say that it's not necessary that everything has to be in this Word document. It can serve also as a place where you say, see this other document for details, if that's maybe where logic rules are stored, or things like code sets might be better kept in a CSV or Excel document rather than in a Word document. So the next slide shows, this is the table of contents for the Word document. So when you see this, we're going to talk about all of the things in bold, but there are instructions for how you would fill out each of these different sections, and it's set up as a table of contents, so it's hyperlinked. So if you click on the page, you'll jump to that section of the form. So going over the major sections. So the request for information is where the PI and the study team would tell you how to be able to contact them and give you that high-level overview that Charlie was talking about. Query description, likewise, is high-level, but a little more detail. What kind of population are they targeting? The beginnings of their inclusion and exclusion criteria, and what other variables are they interested in studying? Variable identification gets into how you would take their study variables of interest and what in the PEDSnet data model that would map to. And then the logic rules is where you get into that as the person generating the query takes all the information they've received from the study team, tries to say, okay, well, how would this look in kind of like if-then logic, maybe tries to explore edge cases to find out where all the exceptions would be, and just make sure everybody agrees on this as upfront as possible as you can be. The output structure sets up the expectation about what data the study team will be receiving, and that is really important to help make sure that there are no surprises later on. Can't promise this will stop all surprises, but hopefully people will know what they are getting ahead of time. Code sets, this is really how, when you start talking about a study that has a diagnosis of interest, a treatment of interest, there are many different vocabularies out there, and we need to be able to map them to our standard data model. So this is a good place for a time-intensive task, but basically a way that we can get all of that information to give them the best data set as possible. And then the index of this document actually shows an example that's been worked through of some of these different tables, and we're going to use that in the next slide to tell you how it would be populated. So for the data variable identification, this is the example that's in our index. So this is really just focusing not too much detail, but it only talks about the data variables and the different domains that we are interested in. Logic is going to come later, but in the first column, you see these are the different domains: demographics, visits, diagnoses, and the data model. Cohort identification would call out the domains that are going to be relevant to for the inclusion-exclusion criteria. So this study is about children between the ages of 5 and 10, so demographic data there, who've had in-person visits, face-to-face visits, so outpatient, inpatient, ED, and who have diagnoses of asthma. But we are not including the procedures, meds, immunizations, other things there. Other variables gets into just other things that are not necessarily required to identify the cohort, but other variables in those domains that they are interested in. So race, ethnicity, gender, and demographic, etc. You'll see that procedures was not something required to identify the cohort, but they are interested in X-rays. So that's where they might call out the different types of things they want to know about, or medications. Again, not a requirement to enter, but something that they would want to know about. A study variable doesn't always have to be something that's purely in the PEDSnet data model. This may be a combination of data variables and logic. For instance, in diagnoses, they want to know about all inpatient discharge diagnoses, fine, but they only want to know about respiratory-related outpatient and ED visits. So that would be a combination of diagnoses and visits. And they would say, see their code sets for elaboration there. So this is how logic rules would play out. So this gets into way more detail than those very high-level discussions of inclusion and exclusion we get into. But this is where you want to make sure between the study team and the data scientist or whoever's generating this query that you understand clearly their goals. So here they said that to be included, you would only want people who had at least 2 in-person visits of asthma between the ages of 5 and 10. And it's always worth teasing out, is this 5 from the 5th birthday through the 10th birthday, or from the 5th birthday to less than the 11th birthday, everything below that? That's always a sticking point. Those edge cases, explore that with this logic. And then anything to exclude these patients. So if these patients did not have at least 2 in-person visits within the ages of interest, we don't want them included in this data set. And then aside from inclusion and exclusion criteria, you might also want to explore what are some other flags that they want generated and any logic that goes in there. So oftentimes we're asked about complexity. Studies want to exclude patients who are very complex. And so that might be a place to spell out the logic that they would want to define complexity, or other rules. So those could be things that, this data set does not want to include any certain sensitive information around HIV or pregnancy-related diagnoses, or these are just things that would be excluded from their study anyways, further exclusion criteria that wasn't specified above. The output structure. So this is empty right now, but if we generated it, we would basically be saying in each of the different domains or these tables, this is what you would expect. And we would put in the columns from the PEDSnet data model that are relevant from each of those tables that the study wants to get in their data set. Derived variables, again, would be things that are generated that are not exactly a column that exists in the PEDSnet data model. Typically, that's only going to be in the patient cohort table. So this is where usually at a person level, like row level data, 1 row per patient, you are going to have data about the patient. So like, something about maybe the age or demographic information. But then you may also want to have some flags of interest to summarize: number of visits, complexity, flags, etc. And so that might be the derived variables that you would be including there. Now, code set identification. So again, I said this was time intensive, but this is basically a place where oftentimes the study investigators will come up with with diagnoses that they're interested in, but they may tell you, I want all diagnoses of asthma. They might be willing to give you the ICD-9 and ICD-10 codes for asthma, but for our data model, we have to translate that, map those to SNOMED. So this is a place that, depending on how many codes there are, you could put the codes here. So the domain would be like condition, it would be about asthma, the vocabulary might be ICD-9, ICD-10, what are the codes that they have in code set. Concepts would be like the concept IDs in our data model, and any additional notes. Again, this is probably hard to do in a Word document, so you may reference files, CSV files, or other flat files that have these code sets. And anything the provider can give you upfront will be very useful for generating this. Similarly, if they give you medications of interest, you'll have to map those to other things like RX norm, depending on, usually PIs don't give you every single code that you want. And so just kind of, going over all these different sections again, I'm going to highlight like what sections we think the PI should be doing, kind of solo, what should be done in collaboration with the DCC or data scientist, and what does the data scientist typically do on their own. So request information, query description, those are pretty much for the study team to generate first. Variable identification would be great if the study team would take a first pass at this, and it would also help them get versed in what the data model can provide. If they can look at that, they might know what they may only start with asking of those variables or saying, you know, what variables could we generate, these variables of interest. Logic rules are something that the data scientists, after they get the previous 3 sections from the data team, this is where they would start saying, okay, this is how I'm interpreting this study. This is how I would build out the logic. Does this make sense? And this should be a discussion, a collaboration with them. A phone call is usually best to set up some time that you could send emails beforehand, just so that it's not being seen on the fly during the conversation. And then alpha structure would be something the data scientists would also put together. And then lastly, code set identification. Like I said, if you could get a head start with anything that the study team can give you, great. But this is likely going to fall a lot of effort on the DCC data scientists to generate this. And it's important to also make sure that we have agreement on what are the variables of interest. So giving them the opportunity to review those code sets at some point to make sure there's agreement and they can tell you, include these, exclude those, etc.
Connor, really quick, I'm sorry, this is Daksha. I apologize for interrupting, but while you go forward, I'm just going to ask a clarification question. The study team is the sites, right? Where the request is originated, is that correct?
Yeah. It would be the PI at the study team, or maybe somebody else in their research team who they are delegating to communicate with you.
Correct. But in your previous slide, when you mentioned, if you can go back to your previous slide, and it says logic rules for queries, both DCC and the study team. The study team say Seattle gets a query for PEDSnet or a project. We have Tamara as the PI. And then we, from the informatics lead, Vicky and me, will be involved with Tamara talking to the DCC to lay out the variable depth identification or the logic rules. Is that correct? Is that how I read this?
Yeah, so anybody involved at the site, including the PI, yes. Sorry.
No, that's okay. I'm waving from the other side of the room. We may be introducing some language confusion here just because of the change we're trying to catalyze. When you see us talk about the DCC here, we mean whoever is managing the query, right? So we you know, like if Tamara had a study and it was going to run in PEDSnet and Seattle was the lead data site, then you and Vicky would be representing the DCC in that case, and you would be collaborating with Tamara.
See. Okay,
right?
So my whole thing, I've been confused because I think as CHOP as the DCC. Right? Yes,
I think we realized that sort of as we were talking too. We talk about this as the DCC without walls, and essentially what our mental model is that whoever picks up the data lead will be functioning as the data coordinating center for that project. We will always be here to help. So the crew at CHOP can back up the study data team, but you don't have to come back to us to vet everything.
Okay. Sorry, Charlie. Now this all makes sense. I was really very confused when I was trying to read this. Thank you.
Yeah, I can imagine. Looking at it from that perspective, I can see it would be a total pretzel.
Thank you.
Great. All right. So, and just quickly, the goal here is for this kind of form is to really try to manage investigator expectations. That oftentimes when people get the data, they might realize, oh, I also wanted additional variables, or, oh, could you do this extra analysis or something else? The spec form is really hopeful that hopefully going to help set expectations. People know what output they're going to get. We'll try to minimize the surprises in the data polls. And so oftentimes, as I said, common last-minute issues have included additional variables not originally requested. Sometimes your study, they're planning on publishing. As Connor said, one of the goals is to publish this stuff. Some, excuse me, some journals require attrition tables or study flow diagrams that show how did you, with your inclusion-exclusion criteria, how did you go from like a huge number of patients, your total population, down to the population that you're studying now. That's something that may not be in the table here, but that's something that you might want to request when you are talking with the study team. Are they going to need that? And then, you know, asking the investigators to commit to this as best as possible. Can't guarantee it's going to stop all surprises from happening, but at least it can set expectations of the work you are going to deliver. And if anything else has to be negotiated after the fact, you can go back to this document as this is what was promised. Go from there.
Cool. All right, thanks, Levon. So I know the form sounds like a lot, but we do ask everybody to use it for all but the most trivial data requests. And we do that partly because it helps to frame the question for both us and investigators and prevent gaps. And partly for the reasons that Levon just mentioned. You know, we're in an unusual situation here in that most investigators are used to working with analysts who are part of the study team. And we want to help. We want to make studies succeed, but we also recognize that we are not typically signing on to be part of the study team because we just don't have the bandwidth to be that present on every study. So part of what this form does is try to focus and crystallize the data request so that when it goes back to the analyst who is on the study team and who will interact with it over the long term, they have the information that they need and can execute the study successfully. The risk we're trying to avoid is that once we've delivered the data, you know, 2 or 3 months from now, we'll be in the middle of another project. And if that's the point where they discover that there is some crucial piece of information that they don't have, then it often means that, you know, either there's a fire drill on the data side, or the study ends up having to wait some period of time until a data scientist can rotate back to it, or both. All right, what questions do folks have about the specification process and the form?
This is Suzanne McCann. I have a question about how many requests you tend to get.
So the answer to that depends on when the next NIH grant deadline is. We have turned around in the last couple of years about 60 requests. We have periods of time where we will go 2 weeks without a request, and then we have periods of time where in a week we'll get 4 or 5 of these.
And then do they tend to be requests for just generally a number of patients that meet a certain criteria, or for the whole data set?
So both. The key, we do get a lot of feasibility requests, and that one spikes before the grant applications go in. The key issue there is that although the result of those kind of feasibility queries looks really simple, the process is often not, because the investigator would be coming and saying, here is my study with 4 inclusion and 12 exclusion criteria. Can you give me the number of patients who would be eligible?
Yeah, it's almost as much work as giving them a full data set.
Yes, exactly.
Hi, this is Angela. I have a question about IRB documents and things. What is the expectation of us to review those documents and make sure that what they're requesting has been approved?
That is the perfect lead in to the next section. So hang in with me for about 5 minutes and I'll talk through that with you.
All
right,
Kevin from Colorado. Sorry, I just quick question. So, in terms of, so you were talking, with regards to like whether it's a feasibility query or a more detailed and the time you're spending, and then whether there's those, I guess what I'm getting at is are there guidelines on, you know, if it's a paid request versus an unpaid request, what are the guidelines on what you'll go back and add or work on, you know, if they've missed something that was not in the original request?
Yeah, I will say that we have done a lot of stuff on a loss leader basis as the network has gotten started up. We are trying to be a little clearer about managing expectations there. You know, feasibility queries are feasibility queries. They don't involve a huge amount of debugging and that sort of thing. But there's also, as you point out, the question of funding and you know, how much time can we dedicate to somebody? That doesn't correlate well with what the investigator expects. So we try to manage that.
Okay. But you don't have any particular set of guidelines that you figured out? You're sort of figuring it out on a case-by-case basis, or?
Yeah, you know, I will say that we have articulated some guidelines. Right? So we have broad guidelines like feasibility queries don't involve iteration with the investigator to revise the query. Feasibility queries only produce aggregate data. Feasibility queries can't take more than 10 hours of effort. But I think as I look around the room here, you know, everybody in the room can remember the 3 times that we violated those rules that, you know, on their particular projects because we were trying to be good to investigators.
Right, okay.
All right, so those are great leading questions. Let's talk a little bit about what actually goes on to evaluate the data request. And I want to start, to your point, Angela, with the regulatory considerations. So part of that front door process is that the investigator engages with the project management office at PEDSnet, and part of their responsibility is to work with the investigator around necessary regulatory approvals. So, you know, does the study need an IRB review? If it's done, if it does, has it been done? Have all of the involved sites either reviewed locally or relied? Things like that. Are the right data sharing requests in place? So with respect to fulfilling data requests, what you need to do is coordinate with your project manager and essentially get from them the information you need. We have not traditionally asked of our data teams that they be involved in drafting IRB protocols or pursuing IRB review or going and talking to local counsel about data sharing agreements. That's what the PMO is there for. And so in any PEDSnet study, you'll coordinate with the PMO, and you'll want to check before you hand out data that those things have been dealt with, but we're not asking you to deal with them primarily. We do engage in a set of practices that are designed to reduce privacy risk. We'll talk more about these in detail later in this conversation, but part of what will also be part of the conversation with investigators is what's reasonable to ask for, what's not, what's reasonable to get in the data, what's not. Right? But let's start early. Let's talk about the administrative requirements. At the PMO level, and again, this is not something that you need to do as the data team, but at the project management office, someone is handling contracting and budgeting and making sure that effort is paid for. Someone is making sure that the committees have reviewed this and that whatever regulatory and institutional decisions need to be made have been made. Someone is making sure that the study is in the right place in the queue that's set up by the research committee. And then when we send out a data set, someone from the project management office is making sure that all of the institutions whose data are represented know that and have agreed to the use of their data. So these are things that kind of come to you as boxes to check off, but not things that you need to make happen. To give you a little background as to what that process looks like and to help advise investigators at your site, we have what's called the Data Governance Grid in PEDSnet. This is a process to which all of the institutions and their IRBs have agreed based on the type of request. And so you can see things like aggregate counts that are prepped to research or feasibility are things that we can execute without further review. We have blanket approval for those. Aggregate accounts that are going to be published require the executive committee to say this is a PEDSnet study, but once that's done, there's no need for IRB review. When person-level data sets are going out, how much review is needed depends on how much personally identifiable information is in the data set. And there are 2 pages full of detailed information. Don't spend neurons committing this to memory, but just understand that this is the dialogue that the project management office is having with the investigator to decide whether an IRB needs to review it. If they review it and determine that it's not actually human subject research or it's exempt research, which is an increasingly common finding under the new common rule, then what's the process by which everybody else agrees to that, and so on. Okay. On our end, we sort of pick up after that, and we step through this process of saying, all right, let's figure out what it is we want to get to. Step 1 involves the specification that Levon was talking about. Let's figure out how we're going to get information back to people. One of the things that you'll want to do before you write any code to query, to pull data, is sit down with the study team and say, here's how it's coming back to you, so that you know what columns you need to fill in a table, or what columns, what rows you need to put into a data set. Right? Once you have that, then what you do is typically you write an initial data pull that includes people that you plausibly think will be included in the data, but doesn't apply all of the criteria. Right? And this allows you to do things like check the quality of the data, see how different inclusion criteria function, without having to try to evaluate the entire study in one big ugly function, and then not know where you lose data. Once we have code that's working to get to our enriched study population, that gets packaged up, and it gets sent off to anybody whose data don't reside at the DCC, so that we can collect those data and merge them, right? And then when the data are in parallel with integrating those data, the data scientist is continuing to refine their code. This often involves back and forth with the study team. They may be saying things like, okay, you are interested in exposure to a drug. Do you care whether that's in the outpatient or inpatient setting? So we know what goes in that table. Or you said you wanted steroid use. Do you care about whether that's oral, parenteral, or topical? So we know what codes go in code sets. Right? So that goes in parallel, so that down in step 5, the data that's come back that is plausibly related to the study meets the code that has been refined and gets you to the exact results of the data request, and output is generated. Once you have that output, the last thing you want to do before you release it, is check to make sure that all of those regulatory boxes have been checked and you've done all the things that you need to the data to meet the privacy risk reduction rules. And then those data can be returned to the investigator and archived at the DCC. All right, so we'll talk through what this looks like in detail for different kinds of requests shortly, but this gives you an overview of the process. Some key things you want to think about. You obviously want to start with, what does the study team want to know about this, and map that to data. That's where the specification process helps you. You want to ask yourself, how much effort is this going to take, so that you can budget time, and if this is part of a grant-funded request, we can budget effort appropriately in the grant. That often involves things like how many code sets are going to be required, because each code set requires curation. What analyses or derivations are you going to be doing? How do you manipulate the data? How many separate cohorts do you need? Do they need to be matched? Do they need to be non-overlapping? Things like that. As you think about it concretely, generating things, you want to ask, how do I get to the data the investigator needs to conduct the study without pouring in a lot of data that they don't need? And what are the intermediates that help me do that in an efficient way and see where problems are developing? Okay. Again, this is probably a familiar concept to people who have done things, but we cannot emphasize strongly enough, alongside the process of specifying well, use intermediate data sets. Don't assume that you can go from step 1 to step N and everything will line itself up nicely. You want to be able to see how things evolve. We all know how good and not so good our EHRs are and where we need to pay attention, right? So our standard is that we use intermediate data sets that successively narrow the population. We may not create an intermediate data set for something very broad like every patient with a face-to-face visit. But if the study inclusion criteria are patients with asthma seen in an ED treated with steroids, you will likely see us creating an intermediate set of patients with asthma, and then subsetting that to get patients seen in an ED, and then subsetting that to get patients treated with steroids in an ED, rather than trying to apply all of those constraints at once. Because if you apply them all at once and the number you get in the end doesn't match expectations, you don't know where you went wrong. Our standard is to save those intermediates off in a study-specific schema. Part of what we'll do in the workshop is go through how that's actually set up. That schema gets retained and archived as the source of truth. So if the investigator comes back a year later and says, hey, I need to redo something in order to address a reviewer's comment, or I need to check whether vocabulary has shifted, we have that structured schema. And we're not running around trying to find somebody's CSV file sitting on their hard drive. You can use these narrowed intermediate data sets as a way to facilitate local copies for computation that's CPU intensive and doesn't operate well, in a DBMS. But mostly we want these so that you can see the data and keep track of the data and keep track of the quality of the data. All right, so that's the broad process. Given time, what I'm going to do is hand off to Hanya, who is going to talk about how this actually becomes reality, and ask folks to sort of jump in with questions as they come up. Over to you, Hanya.
Sure. So we're going to do two types of requests. So one that produces aggregate / kind of analytic output, and another that's person level. So first we'll talk through the aggregate. So some common aggregate data output types, there's the normal like table one-ish type things where people ask about demographic distributions and just high level, ethnicity and sex and age distribution. Attrition table, which is something that also Levon touched upon, is how did we get to a cohort of interest? So how do we start with the universe of patients and then narrow down to our cohort, and what is the step of each one? Incidence and prevalence of certain conditions. If people want to know incidence of newly diagnosed cancers each year, that would fall under this, or the prevalence of drug utilization in a cohort of diabetic patients or something like that. Then utilization is for a selected cohort, all of the utilization patterns, and some more detail of that. And you can see how that interacts with the above, but it's just very focused on utilization patterns for very selected and curated cohorts. And then the health system level type of information is number of visits, specialty visits, and follow-up time, and this sort of thing that people want to know to kind of get a sense of how often people are using the health system they're part of. So some considerations that we need to have when we're doing this is we usually should, in the back of our minds, be thinking about attrition and how we got to a cohort. The code sets are pretty much, everything. And what are the things that the investigator wants to know? They won't know how to translate that to our data model, and so they'll need a lot of help with that. And then, for the output, the small cell suppression. So here's an example. So the GLEAN network is a network that the nephrology group, the nephrologists at PEDSnet have created, and they've done a lot of work. And one of their first things that they've done is develop a computable phenotype for glomerular disease. And so this is from the paper that they are in the middle of trying to publish. So for this, as you can see, there's two different cohorts of interest. This is mostly health system type of follow-up table. And then so they are interested in some like diagnoses, events, and then the CKD stages, and then some health system in terms of the number of hospitalizations and nephrology visits. So this is just an example to kind of guide us through what output might look like. So there's some just basic counts, aggregate counts in the first two boxes you see, and then as you get down, more kind of analytic, like medians and person year computations. So as we were going through this, there are a lot of questions that we had to answer. So how are we defining the sub-cohort that you saw? So there was the full cohort and the sub-cohort. How are we defining those? And what are the metrics that we need to understand the differences between these two cohorts? What are the data domains that we needed? And then how are we mapping the data model elements? So for a nephrologist, CKD stage is just, a thing, a CKD stage. For us, we have to think about it in terms of, okay, well, that's computed from eGFRs, which is computed from creatinines with some extra information. And so we need to be able to not only know which data elements, but think through, okay, let's say someone has a creatinine, but they haven't had a height measured in like 3 years. Is that going to be an accurate measure? How are we going to compute that? So those sorts of questions we need to begin to ask ourselves, and that's what happens when Levon talks through the logic of the query. These are the kinds of things that go into that section. So another thing, nephrology visits, what counts as a visit? Is it any interaction? Is it, would telephone encounters count as a visit, or are you requiring an actual face-to-face? And so it's these sorts of things that we need to think through. And then, again, this is for determining complexity. So how many code sets are required? And so we talked a little bit through this. How many cohorts? This is for 2 cohorts. And then just thinking through what analyses need to be done. And so, for example, for computing person years, we need to understand what are we considering follow-up, and what do we do with patients who are seen just a couple times, but then are then like dropped off the network, because they stop having glomerular disease, but because they moved or they're taking their care elsewhere. So how do we deal with that right sensor? So these are questions that we work with and in terms of trying to determine complexity. The process and output. So we talked a bit about intermediate tables and trying to be overly inclusive. And so these tables help us to create the output and then also help us to kind of manage what we're doing. And so for the GLEAN cohort, and I'll show you a couple of example intermediate tables, what we did was we created categorical level output and then a person level output. And for each one of those, trying to compute what each one would be. And so it's easier with the example, but there really is no right way to do this. We could have just created a table that had everything person level. So you got to try to balance what would be most useful to try and take and create that data set to work from, and what the initial data pool will give you that will most easily translate to output that you can use. So let's just go to the next table. So these are the intermediate tables that we created for GLEAN. And so you can see for the categorical variables, we specify the cohort, what the concept was, and then the actual output. So, year of first diagnosis for the nephrotic patients, in 2018, there were 75 patients. And this was, again, this might be more or less complicated than what you guys decide when you have your own thing, but it's important to have some sort of intermediate way of looking at the data. And then for the person level outcome, the measure, follow-up in days, which cohort it was, and then what the outcome variable is. So should I continue with person level, or should we pause for questions?
Anybody have questions? Okay.
All right. So person level. So when we create these person level data sets, there are a few things that we have to consider. So we have to determine what the complexity is, and we talked a little bit about that. So how many code sets there are, what kind of derivations are needed, the difficulty in deriving these, and what kinds of computations are needed at the DCC. So we had a request for excluding or flagging patients who are medically complex. So that requires quite a bit of work, and to determine what is a medically complex patient. So we've developed some reusable code for that, but doing that the first time was time intensive. Engaging researchers, we need to be able to engage researchers very early and be able to get them used to the idea that this data is just messy, that there isn't an easy way to work with the data, and that's just, it is what it is. And I think you have to balance the requirements for analysis with data privacy. So here, the request for give me all the data, which is what we normally get, so they're like, oh, we just want to study diabetic patients, just give me all the data and we'll do it, is not feasible, and that's not what we should be doing. The general rule is that we give the minimum amount of data needed to complete the study while providing enough sufficient data for sub and sensitivity analyses. And there's no hard and fast cutoff. It's really at the discretion of the person working with, and then the kind of a data coordinating center thing, and honestly the research committee as well, because it involves some level of data governance. So we kind of try to tread that line pretty carefully. Determining level of data quality and data investigation. Because the data are inherently messy, sometimes we give out data sets and people come back to us and say, this data is really, really bad. And in the past, as we're building our network, we've gone ahead and kind of tried to work with the investigators to do some manual mapping to source values, for example. But that really is not something that should be done if there isn't a lot of funding, or if the research committee decides this isn't where a lot of time should be committed. So these are just kind of common traps, but these are things that we have to think about as we are developing these data sets. So I'm going to kind of go through this quickly, the determining the output, because Levon talked about it during the specs section of this. There is one table that usually contains meta-study information, like the flags for major exposures or outcomes of interest, a flag for complexity, for example, and et cetera. And then the rest of the tables are usually similar to the PEDSnet data model. We provide primary keys where we need to, and then we should really be documenting on that spec form where the logic is. So I'll go through an example. This study is one of the first studies that we've done, and we were working with Nemours here, who actually did a lot of the query writing and working in collaboration with us. So this study wanted to look at onset of asthma and development of obesity. So there was an index visit, which was the first visit in the system with no asthma diagnosis, and then when they developed asthma. And then each case patient was matched to a control patient. I'm sorry, I got that backwards. The obesity and the subsequent development of asthma. And so then each case patient at that index visit, they're either obese or not obese. And then based on that, they looked at asthma outcomes. So go ahead. So the output was the cohort table. And so some of the metadata information that we included was who the person was, their matched patient, whether they were case or control, and then some, the payer was a marker for SES, demographic information, the site, the age at the index visit, so that's when the BMI was determined, the first visit in the system, the date, and then whether they were obese. And then some of the other tables that we included were conditions and drugs and visits and measurement. And then we always include a lookup table that includes all of the concept IDs and their matching names, so that people know that 250.00 is a diabetes concept. So that's an ICD. We don't use ICD. So again, things to consider as we were doing this. So the asthma study in the asthma study, what is the question that we want to look at? And then what are the data domains? How are the data model elements mapped? And so they wanted to look at obesity. How are we defining obesity? And so we had Z-score derivations, and we had to determine what the cutoffs were for that. And then we had to determine which patients to exclude. And so that took some talking through with the investigators. In terms of developing code sets, we needed to balance asking for, all patient data, because this was a huge cohort, with what's necessary to answer the research question. So the balance that we came across is, because the cohort was very, very large, because it was just any patient who had an index visit within a certain period of time, and who had some exclusionary diagnoses that, and they had not have asthma at the time. That's a huge number of patients. And so because of that, we couldn't give like all conditions and all visits and all drugs. So we really narrowed down the list of the measurements and drugs and conditions for this study. And so we gave them a large cohort, but the number of the number of data elements that we gave them was small. And so again, we did the matching on our end and then gave it to them. So what analyses must be performed, when we discussed with the with the study team, we kind of determine what are the things that we do on our end versus what are the things that they'll do in their analysis on their end. And so I know I'm looking at the clock and I don't want to take up too much time, but in terms of the intermediate tables, when we created kind of the analytic tables, we created very broad level code sets. For example, the team wanted inhaled corticosteroids, but we just included all steroids and then kind of played around and narrowed down the cohort, the code set as we needed to, and it gave us more time and a thinner data set to play with. And then how can the data be represented in a way to ease computation? So that's the creation of that metadata table. So I'm going to pause again. Are there any questions here? I think we just went through a lot of information.
Okay, well, thanks, Sonia. That was a ton of information. We hope that in part it serves as a kind of useful walkthrough to give you a sense of what some of the major decisions you need to make are, and to go back to the specification process. These are decisions you're making up front with the study team. Not that you can't iterate, but it looks different because you're not there for the whole study. And also partly to give you a sense of what best practices and pitfalls are out there. In a similar vein, I'm going to hand over to Kim to talk a bit about the practices and tools that we use. And like the specification form, we're not holding these out as the platonic ideal that should be used at all times and everywhere, but they are what we use here and what we will use in PEDSnet because we need uniformity of process.
Great. So when you're moving throughout the data request process, it's important that you have certain tracking tools in place, not only for yourself to look back and be able to find that spec form easily or to find interactions that you had with PI, but also so that you can collaborate with other people who are working on the same project. So there are kind of three different categories of tracking tools that we use. One is task management. So this is where you would keep track of background information about the study, where you would keep the spec form, and where you would keep kind of your day-to-day progress on the study. It's also important to have version control for your code, so you can track different changes that you've made to the code and can go back to old code if you need to, and you can collaborate with other people on that code. And also wiki pages where you can go to, where you can find information about maybe a process that you're trying to follow that you know that somebody has done before you and has documented, and you can go to that and follow that same process, or also where you can share information or record meeting minutes. So the task management software that we use here at the VCC is Jira, and in Jira we're able to input different information about the study, like who the PI is, what site the study comes out of, and other background information. And we can also put different attachments in our task management software. So we can put that spec form right in a JIRA ticket where we can look back at it. And also a cool feature of JIRA is that we can link our tasks in JIRA to development branches in Bitbucket, which is the version control software that we use. So you can track changes to your code as you track your daily tasks. So this is a screenshot of what our instance of JIRA looks like. So you can see here, this is our, what we call our parent task level. And this is where we'd capture information about the study as a whole. So you can see in this top left screenshot, we have the lead investigator, the title of this study, and a brief description of the study. And then we can also track information about this parent task on a kind of a more granular level, as you see in the on the right-hand side, where we have subtasks of this study. So within this study, you might want to know when the study is, or when you're developing specs for the study, and then when you're developing the query, and then maybe when you're when the code is going through code review. So you can track that at a subtask level. And this is a screenshot of what our instance of JIRA looks like at a subtask level. And you can see we can capture information such as the date that it was created and updated, and we can put a due date if we have that information. And you can also assign these different subtasks to whoever is working on it. So if you're collaborating with another data scientist, you can open up various subtasks for this study and assign the subtasks to different people. And you're able to quickly check in on the progress on the study. And you can also see on the right-hand side, the development section of JIRA. And this is really important that you can link to Bitbucket through this JIRA task. So you can just click right over there on where it says like 4 commits, and you can go see the commit that somebody pushed for this subtask. Okay, and another type of tracking tool that we have is Confluence, which also links to JIRA, which is really nice for our purposes. So you can document different processes in here, record meeting minutes, you can collaborate on to-do lists, and basically it's just a place where you can document. So this is a snapshot of what our instance of Confluence looks like. And you can see here, we can all collaborate on this data science training syllabus. We can add links from this Confluence page to different JIRA tasks that we can assign to different people who are working on putting together materials, for example, for the data science training. And you can also see on the left-hand side a menu of all the different pages that we have. So you can quickly scan through, and let's say you want to look at meeting minutes from a data committee call last Friday. You could go in there and you could click on the date of the meeting minutes and take a look at what was talked about. So it's a nice one-stop shop for if you're trying to look up, has anyone documented a certain process, or is there any documentation on this study? And the third type of tracking tool that we use, version control, which we use Bitbucket. And as you all likely know, we also use GitHub. So GitHub is kind of how we interact with you guys at all the different PEDSnet institutions when we're talking about data quality issues or sharing publicly shareable code with you all, or even we're also housing the data science training materials on GitHub. But internally in the DCC, when we're working on code for different studies, we use Bitbucket, mostly because we are able to link to those different JIRA tasks, and we can check up on progress on the studies by looking through our Bitbucket repositories. So this is a screenshot of what our instance of Bitbucket looks like. And this query here follows in the standard R framework, which we'll be introducing to you in a future session. But we're able to collaborate on code through Bitbucket. And you most likely have worked with the version control software before, like you probably use Git for GitHub. So you can clone the repository, you can create different branches if you're working on let's say you're sending code to a remote site and you make some changes to the code, you might want to put that on a different branch, or if there are different milestones for the project, you might want to create a different branch for each milestone. So you can utilize all of these features in Bitbucket. And this is an example of a study where we linked JIRA issues to that Bitbucket repository, and you can look for each commit which subtask within that project in JIRA links to each commit. So you can just click right on that link and go to that JIRA issue and then read back on the background information for why that change was made.
Okay, thanks. So I'm sure that everybody is used to using some sort of tracking system. Certainly if you work in a technical shop, it may be JIRA, or it may be GitHub or some tool. These are the ones that we use in the DCC, and we'll ask everybody to use so that we can, everybody has visibility into the work each other are doing, right? We use that task subtask structure to manage projects and tasks on projects. And we are big believers in granularity, not because we want to create overhead, but because if you want to see where you are, it doesn't help if there's one ticket that gets open and doesn't get updated until the study is done, right? And if you want to know where things work or how to pull pieces out of an analysis, it doesn't help if there are two commits in the repository, the blank directory structure, and the final query, right? So please do interact with these version control and tracking systems frequently, commit early and often. The reason that we separate the version control is that we're trying to preserve investigators' confidentiality, and so we don't put those things out on GitHub. All right, any questions about the toolchain? Okay, great. I heard some movement, so not everybody is asleep. So we want to round out on a sort of post-processing topic, and that deals with risk reduction standards in the network. So people come to use the network because it has rich data, it has data on large populations, and we want to facilitate that science, but we also want to limit the risk to the privacy of patients, particularly those who have unusual treatment pathways or rare diseases. In some cases, the most effective tool for risk reduction is not giving out data, right? Is framing a data request as an analysis that's done by you, by someone in the DCC, so that there isn't a data set leaving and getting us to a place where we don't exactly know where it landed. When we're dealing with data, we have a set of standards for reducing identity risk, right? And in particular, we're trying to manage two kinds of risk. There's the risk of direct re-identification, which we can actually avoid by use of things like limited data sets and the way the architecture works, so that it's never the case that PEDSnet will generate a data set and send it out that has somebody's name or social security number or address in it. So you can't look up the patient in the phone book. The place that we have to spend more time is around indirect re-identification, about the situation that happens when there's enough information about a patient that if you can line it up with another data source, you can figure out who that individual is. And that's a risk for us, in particular, when the study team is within PEDSnet. And everybody is approaching this with the right frame of mind, we hope, but it is sometimes almost unconscious or sometimes perhaps a little too irresistible to say, okay, I know that's a kid from CHOP and I'm at CHOP, and I bet you if I went into our EHR and looked it up, I could figure out who this is and find out that one other piece of information we want. And so what we try to do is minimize those risks of re-identification beyond the scope of the study. Clearly, if the study approaches the patient and gets consent for re-identification, we're not trying to throw down more barriers, but that's not our typical use case. When we're managing these risks, we use two major regulatory guideposts because all of us live in North America. On the left side is the rule governing research. This is what IRBs care about, the common rule. And here the standard is whether or not the data are, quote, readily identifiable, quote. right? So not could you find the identity by lining up enough data, but is it easy? IRBs evaluate these things and may decide that there is a risk of re-identification, but it is not readily identifiable, and therefore the research is exempt or not human subjects research. That's okay. One of the other things that is true is that safe data handling may balance the risk of identification. So if you follow the new common rule, for instance, there is an exemption category that says that you may use fully identifiable data, but as long as you protect those data from getting into the hands of people who are not authorized to see it and have not agreed to treat it with appropriate care, that's okay. The data, the research is exempt, right? So in general, much of what we do in PEDSnet is going to be operating at that level. The complement to the common rule is HIPAA's privacy rule. And this is a regulation that's more into bright lines, right? So if these identifiers are present in the data, it is not de-identified. Whether or not, it would be easy to get to it, right? So IP addresses, for instance, are considered identifying information because when the privacy rule was put together, it was a lot more common that people would connect to the internet from home than from Starbucks. Right? And so your IP address was potentially a lot more identifying than it might be today. Here, it's not a question of IRB review, it's a question of what protections need to be applied to the data and what agreements the users of the data need to sign. From a PEDSnet perspective, we almost never, that's not true, we less often operate at the level of de-identified because we need to include dates for many studies. If we can substitute in ages, the data become magically de-identified from a HIPAA perspective. We rarely use fully identifiable data sets. We do things as a matter of routine to try to reduce the risk of patients, and these are things you need to take into account for every data request. We do not disclose source values. So as everybody knows or recalls from the last session, each of our tables keeps track not just of the standard representation of data, but of what the health system recorded as the internal form of that data. So I'll pick a concrete example. We may be looking at a blood count, right? And the standard form of that data is 30.9, and the source value may say 30.9, call to Charles Bailey at 5 p.m. on April 21st. We never give out that source value because we don't want to identify the person it was called to, right? The SIG for a prescription may have the patient's name in it. So source values don't leave, or they're individually reviewed. There's also a level of institutional risk. So we often don't give out the names of the hospitals that patients are at, partly because that pins the patient geographically, and partly because the institutions have a risk in not being identified in data that someone might then misuse to try to do something like incorrectly assess quality of care. So we will often do things like replace this with one-time labels. So you can say these patients are from site A and those patients are from site B, but you don't know which is which, right? For aggregate data, we add some additional practices. We suppress small cells. So any entry in a table that's less than 11 patients, we blank out so that you don't accidentally identify a patient by saying this is the only patient who has this characteristic, right? We don't give out tables that people could intersect. So all of the patients with asthma, all of the patients getting steroids, all of the patients with leukemia. The intersection of those three tables is one patient, right? And finally, we ask investigators to sign an agreement that says we're not going to do underhanded stuff with the data. We're not going to try to re-identify patients. We're not going to give it out to my friends. We're not going to go looking in the EHR for that one other piece of data, right? When we're talking about giving out more granular data, we try to do an additional set of things that reduces risk. We try not to anchor dates in time. So we either shift from dates to ages so that you can't pin a patient to dates. Remember, there's literature out there that says what you need are 3 visit dates and who the patient saw, and with nothing else, you can uniquely identify a patient in the US population, right? So we don't do that. Or if we're handing out dates because the analysis programs require something in the form of a date, we'll randomize those dates within a year while preserving intervals. When we link data sets, we use single-use IDs. When we hand out data sets, we use single-use IDs. We don't hand out the PEDSnet identifier, so we don't create the potential to link the data set from study A to the data set from study B and potentially subset it. And then finally, we routinely remove what is statutorily considered sensitive data if it's not directly related to the study's purpose. So some of that goes to what Hanya said in terms of crafting data sets to match study requirements, but some of it also goes to routine exclusion. So we don't hand out HIV status when we're handing out drug information. We don't hand out antiretrovirals unless this is a study looking at HIV therapy, and so on and so forth. Okay. I've talked about some of these principles, as have other folks, but I want to spend a couple of minutes on this process of less identification as well. And this is the tool that we use to reproducibly and reliably implement these risk reduction practices. It generates single-use IDs, it does the date shifts, it does redaction of or transformation of variables, and when necessary, it does some noise introduction so that if you're worried about generating unique patterns, you can jitter dates within a certain window to perturb intervals in a way that doesn't impair study analyses. Right? So what you can do is take the data set on top, where we have a stable ID for each person in each visit, and we have actual dates and sites, and convert it to the data set on the bottom, where we're using one-time IDs, so you know what data come from which patient, but you can't link it to other data sets, where the dates are replaced, but the intervals are preserved, so that if you want to know how much time elapses between events, you can still do those analyses without needing to know that they happened in October of 2006 or May of 2015. And so that you can aggregate patients by sites without knowing which site each patient came from. So once you've got the final data, you will often be running it through this tool in order to generate the data set that goes to the investigator. In order to do that, you'll need to know something about how the tool is configured and operated. And this, again, is a process we'll work through in the workshop. You need to know how long a date window is. Can the study tolerate a full year date window, or does it need to restrict to a season, for instance? Which columns do you get rid of? We always get rid of source values. Do you also want to get rid of some dates, or do you transform them? Right? If you call something the visit start date over here, and over there it's first visit date, and a third place it's index date, you need to let the software know that those are aliases for the same thing, so it does the same date shift in all three places and preserve intervals. Then the final thing I'll say about the software is that those mappings and transformations are written out by the tool and retained at the DCC, so that if in a future phase of the study we need to re-extract the data, we need to chase down some anomalies, or we need to re-identify patients for recruitment into a trial, those crosswalks are present, they're just not supplied to the investigator. Right? What you end up with is a fairly simple, this is a JSON representation of configuration, where you're saying, this is a study that's going to use the PEDSnet CDM. It should use a certain set of maps to preserve consistent replacements. We're shifting within a 366-day window, so anywhere within a year, that's what's required to move from a limited data set to a de-identified data set in HIPAA parlance. We should pay attention to patient IDs and preserve those because it needs to link to some place, but then other IDs will be replaced with one-offs, right? And so on. And again, we'll go through the details of this in the workshop, and I refer you back to some of the tools that Kim was discussing, where the tool is where Let's Identify is documented, and you can find reference information. But for now, what we're going through this to do is give you some information on what those final steps before data goes back to the investigator need to include. Okay, I want to thank everybody for their time listening, and I know we covered a ton of information, but let me throw the floor open to questions.
This is Kevin from Colorado. Just regarding the tracking tools for either code or like Wiki or something, are you guys expecting that for like a project we would just use whatever internal tools we have, or should we be, I guess, how are we coordinating if we're working with another site such as in DCC?
Sure. We're actually asking folks to use the tracking tools here at the DCC for PEDSnet projects, because that's both the way that we share code across projects, and that's the way that the project management folks can get a view at what's going on, across the network. So part of the reason we use those tools is they roll up into reports that go to the project management office and the research committee that tracks study progress across the network.
Okay, but we're not going to be using GitHub for that, so we'll have to be figuring out what those tools are and learning those tools as well.
Yeah, we're going to try to keep the learning burden low, but we will connect you to all of the tools here. We can't use GitHub at the moment because we need to use a hosted tool that doesn't put the data outside the data network.
Okay.
Other questions from folks? Okay, then, let me say thanks to everybody for your time. I know we covered a lot. We will post the slides and the recording so that folks can go back over things. And as usual, by Monday, we will have the post-webinar exercises out for everybody to dig into. Have a great afternoon.